Thank you very much, everyone, for giving me your attention. It's great to be here in Winchester. It's actually my first time in the UK outside of London, so I'm half expecting some sort of Midsummer Murders style mystery to occur on the boat ride tonight. Okay, so today I'm going to be talking to you about colourful graphical fonts in OpenType. I just noticed while I'm in the UK, I guess I should spell colourful correctly, so let's just fix that up. Okay, great. Firstly, what is OpenType? OpenType is a binary font file format. Came about in the mid-90s after some argy-bargy between Microsoft and Apple about font formats. And it's a table-based format, so there are a series of tables which are named with four character names. There's a head table which has metadata about the font, whether the font is like a boldface font, an italic font. There's a horizontal metrics table which has information about the advance of each glyph. So that's kind of like the horizontal extents, or how far you advance along your text as you place the glyphs. There's a table that maps, say, the Unicode character codes to which index into the font the glyph for that character is at. And basically, OpenType at the moment supports two main classes of fonts. So there are bitmap fonts in the EBDT table, and outline fonts, which are either quadratic Bezier curves or cubic Bezier curves, with those two tables mentioned there. So bitmap fonts, well, obviously they don't scale nicely. They're just a monochrome bitmap, pixels are on or off. Bitmap fonts in OpenType do actually have the ability to say, at this font size, use this bitmap. At this larger font size, use this other bitmap. So there is a bit of sort of support for scalability, but anywhere in between the font sizes that you support, it's going to be scaling like this. And the other one was outline fonts. So this is a screenshot from FontForge, which is an open source font editing program, which is not the prettiest of user interfaces. So this is showing Times New Roman, which has a quadratic Bezier curve format. So actually it's a true type font for the A glyph in there. So the outline fonts just describe an outline of the font, which means that they are also just describing a monochrome shape. So we're going to talk about adding colour into these glyphs. Of course, in the real world, colourful glyphs have been around for quite a while, actually. So from the first illuminated manuscripts, which were first hand-painted like in 400s or 500s or so, there is a pattern of having these large drop capital letters which have some multicoloured designs painted on them, and they often have gold and silver, what would you call it? Filigree? No. Filigree, yeah. Which is where the name illuminated comes from in illuminated manuscripts, because it's reflective. And some of these drop caps can actually be quite intricate. So here's a big drop capital, or Bible case, A, with a sort of detailed scene hand-painted in the middle of it. Another example of multicoloured fonts in the wild is so-called chromatic type. So this is often produced with woodblock printing. So you would layer multiple layers of paint over the one position and carve out different shapes on some woodblocks to get some unified whole of a glyph that has sort of multiple coloured parts to it. So this kind of font here, chromatic fonts, this probably gives you a sort of feeling of it's a Western or something like that. So you can see these characters are made up of three colours. There's a red at the top, yellow at the bottom, and a pinky colour for the sort of shadow or block, and some ornamentation in the middle. And sign writing as well is another good example of where multicoloured lettering is often used. So why should we bother trying to add colour into our font file formats? Well, primarily, it has a bunch of benefits because we can effectively treat text as text and not as images. So at the moment, if you want to represent these kinds of glyphs in your documents, you would either have to have like a rasterized image or perhaps an SVG image, but you've lost the sort of mapping to the actual textual content that's behind them. So if we can encode these multicolored glyphs in the fonts, We can have text which is searchable, so not only find on the page in the browser, but search engines can find them as well. You can select it. You can edit it, as you saw on the title page there. It's accessible because screen reader tools have the access to the text content, and it makes the multicoloured glyphs more reusable as well. So there are a couple of techniques that people can use currently to get some of these effects. One technique is to use layered fonts. So this is where the font author either provides one font with multiple glyphs that are intended to be overlaid over the same position to produce some composite whole, or for the lettering cases, like with the woodblock printing you saw before, often that you have multiple font families that you use, and then you type the text, and then you type the text again, and then you type the text again over the same position to get these multicoloured effects. So here's an example of a font that's meant to be used in this technique. It's called Forecast Font for creating weather forecast symbols. So Ali Sisk has produced a font with some glyphs that match up nicely when you render them on top of each other. So here is an example of a composite glyph produced using this technique, where we have a grey cloud glyph, some blue raindrops, and a yellow sun. And the technique to actually cause them to be rendered over the top of each other is to use generated content and position absolute. So that lets us write one span per component, and then we use generated content to select the right glyphs out of the file. So these are glyphs in the private use area of the font, so glyphs that don't have any specific meaning. And then we just set the colour on them. Another technique you can use is SVG text. So SVG text supports some slightly more effects than regular CSS in HTML text. So here I've got some text which I have stroked with a gradient. So from dark grey to light grey down the bottom, might be a bit hard to see there. And I filled this word here with a pattern. So I've defined a polka dot pattern here with a white background, a few circles, and then with the text I can reference the pattern and the stroke when I render the text there. So there's been some prior work on colourful graphical font formats over the years. The first is probably Type 3 fonts, which is one of the type of fonts that was available as part of the original PostScript specification. So PostScript probably you think of as a printing format, but it did allow you to define arbitrary PostScript programs to run when a particular glyph from the font was called to be printed. It didn't really gather support like natively in operating systems and in browsers either. PostScript's a bit of a sort of old technology now, so it's unlikely that's going to make a resurgence. And another one that some of you here might be more familiar with is SVG fonts. So in the original SVG specification, SVG1, it had this SVG fonts feature where you could include a font element in the document and define the graphical content of your font's glyphs using SVG. And there were two variants that were supported. One was tiny fonts, so they were basically the same as outline fonts that OpenType supports at the moment. So you just give a path string. And the second one was full fonts. So they supported the full set of SVG graphics inside the glyph definitions. So it was kind of an analogue to PostScript Type 3 fonts. Here's an example of an SVG font. So we have a font element here. We define some properties of the font, so the font family name, our design space size, where the baseline lives for the glyphs. And here's an individual glyph definition here. So we say for the A character, it has 700 units of advance, so that's how wide it is effectively. And inside here is the content. So that would mean that the glyph just displays a red circle. And then you can just reference the font as you would reference any font. So SVG fonts have a few good points. So they're quite graphically expressive. And they're easily written by hand if you consider SVG easy to write by hand. It also means because they're in the document, you can modify them with script. So you could produce some dynamic effects by running some script in the document, modifying the glyph elements, and have that change be shown on the screen immediately. And of course, because they're vector graphics, that means they're scalable. And they're also animatable. So SVG's animation features, the smile animation, is defined to work with SVG fonts as well. There are a couple of drawbacks to SVG fonts. It has limited support for the kinds of font features that OpenType supports more generally. So things like selecting small caps or particular numeric variations of glyphs. And it also doesn't support non-Latin languages very well. So beyond some very rudimentary support for Arabic text shaping, it's not really a great choice for non-Latin languages. And when we're defining web features these days, supporting the world's languages is really a must-have. So because of those cons, some browsers didn't end up implementing SVG fonts. Well, I think Opera might have been the only one that implemented SVG fonts full. Some of the other browsers did implement the tiny version. And there was a small resurgence in popularity of SVG fonts a few years ago, at least the tiny version, because mobile Safari, that was the only font format that was actually supported. So you'll see tools like websites like Font Squirrel or these other font repository sites often support SVG tiny fonts, I think because of that sort of historical limitation of font formats on iOS devices. Nowadays, though, you can use OpenType fonts on iOS devices. So popularity has waned again. The other example of multicolored font technology is our friend the emoji. So that's my favorite little fella out of Apple's emoji font. So in around 2009, I think, in the iPhone OS version 3, Apple added support for emoji glyphs in their phones that were in the Japanese market. So in Japan, there's a big history of using icons in text messaging programs that wasn't particularly standardized across different operators. So different operators had different sets of glyphs, different ways of encoding those glyphs. And eventually, Unicode added support for emoji natively. So now there are predefined code points in Unicode for all of the emoji, which is basically, I think it might have been like a union of all of the different icons that the different Japanese handset providers supported. So now there's almost 1,000 in Unicode 7, actually. And on mobile, on iOS 5, that now supports all of the Unicode code points for emoji. And using emojis, like you've got an emoji keyboard on the phone. And macOS 10 Lion, I think, was the first version to support that on the desktop. So Apple introduced this SBICS format table in OpenType, but it was a proprietary format, and they didn't document it. Some people reverse engineered the format, and it turned out it was just a set of PNGs embedded into the font. So relatively simple, but ideally we would have a standardized format for doing these multicolored glyphs so that people can create their own. So a couple of years ago, the working group, which has this quite awful abbreviation there, started working on the next edition of the Open Font format, which is the standardized version of OpenType. And submissions were invited for proposals to support these colored glyph use cases. So there were 3 proposals that were made to the group there. The first was from Google, and their proposal is to support something similar to Apple's tables, where you embed bitmaps into the font. You have a series of PNGs or raw sRGB data, and you can also, just like with the monochrome fonts that are already supported in OpenType, give multiple versions of those bitmaps at different sizes so that you can do some sort of scaling to the nearest size appropriate. So that lets you render arbitrary graphics. It's not going to scale great if you scale it right up, as you can see. Well, that's the Apple format, but that's getting a little bit pixelated there. And it also doesn't support any sort of parameterization of the colors used in the glyphs. So if you wanted to design a glyph which took on the main color of the text in your paragraph, if you're not just doing icons, if you're trying to create some like lettering, then there's no way to actually take in the color from the outside. The second proposal was from Microsoft. They proposed these 2 tables, color and CPAL. And they let you define layered coloured glyphs to support the kinds of things that we saw before with that forecast font icon. So the font defines one or more palettes, and each palette has a number of entries with different RGBA colours in them, just 32-bit values. And to render a particular coloured glyph, you say, well, here's a list of the plain glyphs to render, and here's the index into the palette to render that part of the glyph with. Because of that design, it actually provides good fallback for implementations that don't support the coloured glyph rendering yet. So the two tables, the colour and CPAL tables, if they're just ignored, then you'll just get the base composite glyph rendering. And they're also scalable because they're using the OpenType quadratic or cubic Bezier curves as their basis for rendering. One limitation is that you can only use flat colours as the parts of the layers, so you can't use gradients or patterns like you can in SVG glyphs. So here's an example of how we would actually construct that weather icon using the Microsoft tables. So here is the contents of the palette table. I've just got one palette here. And we have at colour index 0, we have the light grey colour. At colour index 1, we have the blue for the raindrops. And colour index 2 is the yellow for the sun. As for the outlines, the glyph shapes themselves, so let's say we have glyph number 10 is the whole glyph, and then glyphs 11, 12 and 13 are the three components that make that up. Then in the colour table, we say if we want to render glyph 10 with colour, first we render glyph 11 with colour index 0, then glyph 12 with colour index 1, and glyph 13 with colour index 2. So you can actually use a special value in this colour column here. These are 16-bit values. So if you use FFFF, that means to use the foreground colour that comes from the document on the outside. So it is possible to create glyphs that partially take on the colour being used in the paragraph that the glyphs are being used in. So this was supported, this was proposed and supported in Windows 8.1 initially, and I think it's been backported now to Windows 7 as well. So Microsoft wanted to have support for emoji on their touch devices. So they developed a font, Segoe Emoji UI, I think it's called, or UI Emoji, with these flat multicoloured glyphs. And you can actually bring up, if you bring up the touch keyboard in Windows 8.1, you can actually insert that. And here's a screenshot of those glyphs being rendered in Firefox. The third proposal was a joint proposal from Mozilla and Adobe, and that was to embed SVG documents inside the font and to use SVG graphics as the contents of the glyphs. So you embed one or more documents into the font. Each document defines one or more glyphs from the font, and the implementation would search out elements with particular IDs, so ID glyph number, and render the contents of that SVG group or element as the glyph. So this also allows full SVG graphics, apart from a couple of things. So like text is disabled inside the glyphs. I mean, we could have made that work, but it just seems simpler to avoid any problems with sort of self-referential fonts by disabling text rendering inside the glyphs, and often you don't particularly need to render text within the glyphs themselves. And it also supports fallback to plain outline glyphs in a similar manner to the Microsoft proposal. So here's an example of the weather icon, which I've written as an SVG glyph in this new proposed format, and added a couple of SVG features which are not supported in the other formats. So here we have our group elements for glyph number blah blah blah, and we have a path for the cloud, a path for the raindrop, and a path for the sun. So I've added an animation onto the raindrops here, so you can just use the smile animation elements inside the glyphs, as with the previous SVG fonts format. And I've got a gradient here on the raindrops now. So that's real text, so you can select that. SVG grew a couple of new keywords that you can use in property values to get access to sort of context information. So to do the same kinds of things where in the Microsoft table use a special value to use the colour of the text that's referencing the font, you can use a new value context fill in any of the properties that support paints to take the fill or the colour in HTML content of the surrounding text. And you can also grab out the paint value of the stroke on the text and a couple of other things like the fill opacity, stroke opacity, and some other stroke dashing properties. So here I've made a particularly ugly glyph for the letter O. So this is text here which has a teal coloured stroke and a yellow fill. And the O, I want to have a stroking around the outside that matches the stroke of the text. But on the inside, I want to have a filled circle that uses the stroke colour. So to do that, I can use fill equals context stroke to take the stroke value from the outside text and use that however I want on the inside of the glyph definition. There's a little bug there where the thickness of this outline here should be a bit thicker to match this. I'll fix that later. So the Mozilla and Adobe proposal works with the Microsoft palette proposal as well. So the palettes that are defined in the font can be used inside the SVG glyph definitions. And the mechanism for that is that CSS variables or custom properties are automatically defined in the document and can be referenced in your content here. So a number of properties with well-defined names, color 0, color 1, color 2, are defined automatically, and you can reference them in any of the properties. So comparing the Mozilla and Adobe proposal to the original SVG fonts, there are a few differences. Importantly, there's no metric information in the SVG document. So whereas the original SVG fonts had a special font face element which had like baseline information, each glyph defined its own advance, here we use the metrics information which is in the OpenType tables. And we use the SVG documents only to define the rendering, no sort of metrics or metadata information about the glyphs. The coordinate space is Y down instead of Y up for familiarity with authors who are doing SVG graphics. That was one thing that tended to confuse people a bit when they were creating SVG fonts, where the font, you would design the font stuff from the baseline upwards, but now it starts at 0 at the baseline, and if you want stuff above the baseline, you would put negative coordinates. And as I showed on the previous slide, there's better mapping of fill and stroke to parts of the glyph, which you couldn't also do with SVG fonts. And you can use all of the OpenType features for complex text layout, automatic attachment of combining marks like accents onto base characters, defining whether a glyph is a special small cap variant or a lining numeral variant, all of the kinds of things that you could do nowadays with the font variant property in CSS3 fonts. So all of those features in OpenType now work with these SVG glyphs because we're just reusing all of the OpenType machinery for that. So which of these three proposals was accepted? Well, all three of them. Hooray for standards. But I think realistically, there are different use cases and pros and cons for the different proposals. So it's not a terrible situation that we have these three different formats all supported in the spec. So now what I'd like to do is just go through a little example of how we can actually construct one of these SVG glyph fonts. So what we're going to do is create a font that has a plain glyph and has a sort of hatched shadow underneath it and a bit of a gap between the glyph and the shadow. So this is something that you also could do with the Microsoft proposal. You would have to sort of create a path to represent each little hatched bit. But I'll show how it's maybe a little bit simpler to do in the SVG glyph format. So here, this is a little tool that my colleague at Mozilla, Robert O'Callaghan, wrote called the SVG OpenType Workshop. It's not a particularly pretty tool, but what it lets you do is to load an existing OpenType font and to add an SVG table to the font and then see the result of that live in the browser. So what I'll do is I'll load the base font. So I'm no designer, so I wouldn't be able to like produce this A shape myself. I'll just place it there. Okay, so this is the font as it exists at the moment without the SVG tables. I'll add a new SVG document table to the font, and I'll just start with an empty document. And what I'll do is have a group element for the first glyph in the font. Now I know ahead of time that glyph number 1 is actually the glyph for the capital A. That's something that you could look up in font tools if you needed to know that information. Or perhaps this tool should grow a feature to show you what glyph ID you need to work with. So now I have an empty group here with an ID of the right format, and my A shape has disappeared because the group is empty, and now it's using the SVG contents to render that glyph here. So just to show that it's working, so there's a tiny little green rectangle now for the glyph. So what we're going to do is take the existing font path and make some changes to it. So to grab the font path out of there, what I'll do is kind of cheat and open up the original font in FontForge and export it to an original SVG font format. So because the original SVG font format uses the same path syntax, that's handy for me to then sort of extract that out and then include in my document here. So actually I did this a bit earlier and got this document as a result. So I want to grab out the path for the A element, the A glyph. Okay, nearly. So remember I said before that the coordinate system, or which direction Y goes, actually changed between the old SVG font format and this current proposal. So I'll just flip it around. Okay. So now we have our capital A rendered using SVG, and we can get on to the fancy graphical features of it. So to make the shadow part, I'll include this path a second time, offset it a little bit. Oops, maybe the other direction. For the moment, I'll just give it a green colour. Okay. So what we're going to do now is fill this currently green shape with the hatched pattern that we want from our example over here. So to avoid me having to try and work out how to use patterns in SVG on the fly, I've done it beforehand. Here's one I prepared earlier. So here's a pattern element with a few lines to paint over the pattern tile. Put that into my font. And then reference it from in here. Okay, so it's a little bit small. I might just make it a bit bigger. And I'll give it the same colour as well. Okay. Okay, so there we are. There's the hatch pattern underneath. And the other feature of the glyphs that we wanted was to have this little gap here between the shadow and the glyph. So that's a perfect case for masking in SVG. So the approach that I'll use is to create a mask that the hatched A is painted with, and the mask will have pixels so that it doesn't render the hatch at the original coordinates of the A and a little bit around it as well. So I'll sort of put a stroke on the element inside the mask to knock out little bits around the original A. So that is also something I've done before, done earlier. So we have a mask element here. If you remember masks in SVG, when you paint white contents into them, that means that you let the content shine through. And if you have black contents, that means the contents are masked out. So what I'm doing is just putting a white rectangle over the whole glyph cell and then drawing our original A shape with a bit of a thick stroke around it to knock out some areas around that original A. Okay, and then so I'll reference the mask. Oops, actually it should be on this one. So put a mask on our shaded shadow, and there we are. So once you're done with designing your SVG glyphs in this tool, at the bottom here, you can use this link here to save out the OpenType font. So this is a pretty rudimentary tool. So it does all of the sort of parsing of the OpenType font in JavaScript and the insertion of the SVG tables, and it could pretty easily be extended to do things like having an editor for the palettes. Yeah, it's pretty basic at the moment, but at least it can let you have a play around with these font formats. Okay. So there's a little bit of future standardization work needed around this. So at the moment, there's no way in CSS to select which palette you want to use from the font. So in CSS, you've referenced your downloadable Colourful font. And now, let's say you're using the Microsoft proposal or even the SVG one, there are multiple palettes inside the file, which might be good for like bright color background or dark color background, or maybe a monochrome version, or different shades of grey. And you want to select which palette to use, so there's currently no way to do that. So perhaps a font palette property to select which index of palette to use would be good. And beyond that, maybe even specify custom colors to use in the palette altogether. So perhaps you should be able to specify, well, I want color 0 to be blue and color 1 to be orange. So these are some things that are being discussed in the CSS working group at the moment. So hopefully we'll get some resolution on those soon. So the all important million Great British Pound question is, where is this supported? So the color bitmap fonts, that's not supported in any browsers yet. Google has been doing some work to integrate support for that into FreeType, a font rendering library. But Chrome doesn't use FreeType for its text rendering, it just relies on the operating system's text rendering stuff. So I'm not sure what the time frame is to try and integrate that into Chrome, or whether they have to rely on the operating system eventually supporting that. The plain coloured glyphs, so the Microsoft proposal, is supported both in Internet Explorer 11 and in Firefox, some high 20s version. I get confused by the different version numbers these days. Or maybe even 30s, I'm not sure. And the SVG table is supported only in Firefox at the moment. In font editors, so the TransType tool is a tool from FontLab, which so it's actually just a conversion tool, which can take one format and turn it into another format. So all three of these proposals are supported now in TransType. But as for a graphical editor for these kinds of fonts, Font Creator is a Windows tool, and glyphs.app is a Mac tool, which both support the Microsoft proposal. There's no GUI tool yet for the SVG glyphs, but you can, if you're familiar enough with writing SVG documents by hand, you can use the workshop page that I just mentioned to play around with that. Okay, so that's all I had for you today. Thank you very much for coming to listen about these graphical fonts.
This microphone is being very troublesome. Question number 1.
Hi, Cameron.
Hi, David.
The tool that Robert O'Callaghan used, might something like that be available as an API so that one could do that within, you know, the browser environment?
I think that's a great idea, and would well be worth somebody doing. I had wanted to look at that at some point, but time, everybody's got copious free time, right? So the actual way that page works is that it uses JavaScript to parse the font, insert the table, and then it takes that binary content, creates a blob from it, and which gives you a blob URI, and then you can use that blob URI inside your @font face declarations to refer to it. So all of that functionality could quite easily be wrapped up in a script that you could then include in your document. And you could even make a polyfill for the original SVG glyphs. Using that, you could parse out the font elements from your document and then effectively create one of these OpenType fonts that automatically gets used. So I think there's definitely scope for something like that.
In one of your examples, you had the polygon, or what was it, a path, but did not specify a color. It still changed the color. Setting the color property for the font.
Yes, it did.
So usually the fill property has an initial value of black. Sorry. Why did it change to the color property?
Yeah. Okay. So here. So this circle here, there's no fill on here, but still it gets the yellow fill from the outside. So what actually happens is that there is a user agent style sheet which is automatically applied to the document, which does effectively this. Blah, blah, blah. So that on the root element, the fill is automatically set to context fill, the stroke is automatically set to context strokes. Just so that you don't have to say fill equals context fill on all of your shapes. Because it seems like the default that you would want to start with at least. Alex?
Just a question about fill and context stroke. Does that just take flat colour or will it support any paint server?
No, it works with any paint server. So if you've got SVG text here, maybe I should have demonstrated this here, but if you used a gradient fill or a pattern fill in here, then that gets sort of automatically scaled to the same size so that you would see the same pattern in here as well. So context fill in an HTML context means the value of the color property actually. So I think CSS is going to grow abilities to have patterns and gradients on text and strokes on text at some point, in which case then that would be usable there as well.
What about hinting support?
Good question. So because the Microsoft proposal uses the standard OpenType glyphs, so the ones that are defined in the CFF table, which is the Bezier curves, they can also, in the rendering, you can also pay attention to the hinting tables that are inside the font. So that will do things like adjust the positions of the outlines to fit the pixel grid of the monitor automatically. So that's something that the SVG glyphs don't support. There's a bit of a difference of opinion between different people on whether hinting going into the future is actually going to be a useful thing. DPIs on devices are going to increase, not decrease. And some people think hinted text looks better. Some people think unhinted text looks better. It would be sort of a complicated undertaking to add graphical hinting to just SVG graphics. There's been some interest in that from some people, so perhaps in the future, if SVG grows that feature, then it would sort of become applicable to the SVG glyphs. But at the moment, if you want hinted glyphs, you would need to use the Microsoft flat path